So following on from some of our videos, in order for us to understand integration, we need to understand the fundamental theorem of calculus. We need to understand the fundamental theorem of calculus. So we've seen this, we've seen this, we've seen this, we've seen this. In this video, we're going to look at this one here. We need to understand this theorem in order to understand the fundamental theorem of calculus. So looking at that theorem, so this is a theorem here. So let me explain this theorem. Imagine you've got a graph, your xy graph, and this is your function, f of x. This is your function in between a and b. So when you get b take away a, that will then give you this length here, which is this thing here. And if imagine to understand this, imagine you've got a fish tank. So this is your fish tank. And this is your fish, and this is water. So when the water settles, it will probably settle somewhere around here. So when the water settles, I'm just going to guess the water settles around here, and let's just call this height here w. So I would then ask you, how would you go about finding out this height w? Find the height at which the water will settle. For sure, the water won't, remember this is your water here. This whole thing here is your water. When the water settles, it will probably settle somewhere around here. For sure, it won't settle at the lowest point because water is conserved. For sure, the water won't settle here, because if water is conserved, then where did this whole amount of water go? It can't just disappear. And for sure, where the water will settle, let's just say it settles somewhere around here, for sure the water won't settle at the highest point of the function in between a and b. It won't settle up here, because for if it does settle up here, where did this amount of water come from? So it won't settle, the water won't settle at the lowest point, and it won't settle at the highest point of the function. It must settle somewhere in between. So let's call this this level here w. So your job is to work out where the water will settle. And let me rush through this. This c here, the theorem is saying that where the water will settle, it must cross over the actual function itself. It must cross over right here. Because right here, there's a value c. I don't know where c is. C is just between a and b. That's what's meant by this, at some point c in between a and b. So I don't know where c is, but it must cross over the actual function itself. So if you put c into the function, it will jump up to here. And this here is the height at which the water will settle. So that's what the theorem is saying. I will explain more on this later on. But my first question is, how would you go about calculating the height w? How would you figure out this height w? Well, to figure out that height w, what you do is you work out the area of the amount of water you've got. So that would be the integral. That would be the integral from a to b of the function itself, dx. So this thing here will give you the area of the water. So that gives you the area of the water. Now when the water settles, it will settle, let's just say it settles at w. So my question to you now is, which area is bigger? This area here, or this rectangle area here where the water will settle? So, well, if you think about it, because water is conserved, the area of this rectangle must be the same as this thing here. So you can put it into an equation. Well, this thing here is the area of the water. Where the water settles at w, then w times this length here. So w times b. Remember, this length here is b minus a. B minus a. So this equation must be true, because this thing here is the area of the water, and this is the area of our rectangle. You get the height w, and then you times the width of the fish tank, which is b minus a. So now you would then, well, if you want to know w, then divide both sides by the width of the fish tank. So divide both sides by b minus a. So that would be w equals the integral from a to b f of x dx, and then you divide it by b minus a. But then I'm going to rewrite this as w equals 1 over b minus a, the integral a b f of x dx, because this is a fraction. If I were to give you one block times a fraction, it would get multiplied to the top, giving you this thing here. So I can rewrite this thing here as this, which is what we've got. Hang on, let me tidy this up. So which is this thing here. So this complicated looking thing is actually w, the height at which the water will settle. Okay, so after all that, this turns out to be the level at which the water will settle, w. And don't forget, the dimension of this is a length, because it's just a length from here to here. The integral from a to b f of x dx, this is an area. This is the area. This is the area. When you divide it by the width of the fish tank, it will then give you a length, which turns out to be this length here, w. So after all that, this thing here is where the water will settle, w. And the theorem is saying that there exists a sea where the height at which the water will settle is the same height as the actual function itself. You see, if you put c into here, it will jump to the same height. It's impossible for you to give me a function where it's impossible for you to give me a function where the height at which the water will settle won't cross over the function itself. So let me illustrate what I mean by that. Hang on. Imagine you've got a fish tank. Let me just give you a function looking like this. I'm saying that where the water will settle, it will probably settle somewhere around here. You see, right here, it must cross over the actual function itself, f of x. So here, your c happens to be right here. If you give me a function looking something like this, let's just say, so this is your f of x here. Let's just say where the water will settle somewhere around here. So this is a w. You see, right here, it crossed over the actual function itself. So c exists here. So because here you've got more than one c, we're just going to call it c1, c2, c3. Remember the theorem saying that at least one c, at least. It's just impossible for you to give me a function where when the water will settle, it will not cross over the function itself. It's just impossible for you to give me a function. For example, when the water settles here, it will settle around here. You see, right here, it must cross over the function. No matter what function you give me, it's just not possible for you to give me a function where it will not cross over the... Well, here, c exists here, and there's another c here. So let's call this c1, c2. There must be at least one c where there must exist at least one c where if you put it into the function, itself, it will jump to this thing here. So this is a height. This is a height, and this is also a height, and they happen to be the same. Okay, so that's what this theorem is saying. Okay.